So thank you very much for being here. I'm going to get started because it's going to be a little bit of a whirlwind. There's a lot of content to go through. Just a quick reminder, of course, use hashtag CTI Summit. If you really want to say a joke and not mention me on Twitter, just use the hashtag for the talk, which is Beyond Matching, right? Before anyone says, but that's a really long hashtag. So actually it's secure because math was longer than that. I counted the characters, so it's not that bad. So anyway, if you're into the Twitters, if you like your hashtags, there you go. So anyway, who's this guy? My name is Alex Pinto. I'm a capybara enthusiast. And on the side, I do security data science. And I've done a lot of my work. This is me on Halloween. This was Donut Chart Capybara. I've been working for a while now as a chief data scientist at a company called Needle, right? And I've been publishing a lot of this work, this threat intelligence / machine learning work under the name MLSec project. So this is technically an MLSec project presentation as well, but I'd rather not give too many logos and too many names for you to guys to think about. So let's stick with Needle for a while. And a needle, what is a needle? It's an important question, right? We're working with, and this is one of the reasons why I pick at Rob all the time, a repeatable and confident way to do some autonomous threat hunting, right? Which leverages a lot of what we've been talking here on threat intelligence conception on a more automated way, right? So a lot of these results came from ongoing researches for the past 6 to 9 months, what I've been doing at Needle. So I want to give you a glimpse of cool stuff we can do with IOC data, and specifically network IOC data. I will clarify that while you are using, again, trying to improve your own consumption practices. So anyway, first of all, we're going to go through a very brief introduction because you guys probably don't need any. A few spoilers there, and about what IOCs should be doing for you, but you know, sometimes it's not that easy to get all of that from them. We're going to talk about what actually makes analysts effective in using IOCs, right? And how we can translate kind of this code of practice or these processes into something that we can actually codify as data science, right? And maybe get some interesting uses that it weren't obvious, right, as we were getting this data. In learning and expanding our knowledge on the IOC data. So anyway, if any one of you here, this is like, oh, this is my first CTI conference, I'm actually looking into putting CTI into my organization, putting IOC consumptions, right? I'm sorry, I will spoil you on this presentation. I'll tell you how it ends, and it ends in tears, right? So if anyone doesn't want to be spoiled, they're like, oh no, I'd rather watch the movie myself and spend a couple of $1 million in order to do that. Guys, it's okay. The next talk's going to be much better because it's Sergio, right? So anyway, I just want to make sure we get the definitions right. Again, this is a very noisy word. Everybody talks about threat intelligence. So interchangeably here, when I'm talking about threat intelligence, I'm talking about IOCs specifically, right? Which are, of course, very tactical tools that you use in order to identify if people potentially have breached you or not, right? You try to relate them to maybe an actor or a malware family and all those different things, right? And again, specifically, the concepts I'm going to be talking about, they don't need to be about network IOCs, right? Specifically on the endpoint side, you'll see that a lot of the assumptions that I use hold, but we're going to stick with one of them, and this one is actually much easier to explain because otherwise all of you would need to have some sort of background into malware reversing, which I don't, so I probably would also make a fool of myself. So it sounds great, right? The concept that we can actually have these identifiers that are going to be giving us the information on things that are potentially malicious or potentially infected in our environment. But there are two main challenges to IOC consumption, and these are both challenges that I have addressed on past talks that I did, right? The first of all of them is the quality, right, and the curation, and the idea that the feeds that I'm getting from my open or semi-private sources or the feeds that I'm paying for, are they good? And good is a very loaded word again. Are they appropriate for what I'm trying to detect in my environment? Do they have enough overlap between themselves? Are they being refreshed frequently enough, right? So there's a lot of different questions, different ways you can look at those feeds, right? And the flip side of that is actually, how do I get the appropriate information? How do I get the data that I need in order to defend my company in a timely fashion, right? And I was looking at this and exploring this on the threat intelligence sharing presentations where, well, maybe we can get to a significant velocity where people are actually giving them the information that they need to do faster detection. But the problem is, right, and again, I'm citing Sergio, who's going to be up here next, right? He was actually talking about how quality and velocity are most of the times at odds. So if you usually optimize for one of those, right, you'll have a problem with the other. If you want to get your data as fast as possible out there, right, you're putting the burden of vetting and of curation on the actual analysts of the receiving organizations and not so much the organization that generated the original intel. So I love when people talk about how people should be, again, revising their own incidents and generating their own threat intelligence, but to actually have this intelligence that you're generating internally for your detection purposes to be in the level of context and the level of quality that will actually make it helpful for other organizations is actually a much higher bar than most of us are used to or would be actually willing to invest the time and the resources into doing. So anyway, I have absolutely nothing against threat intelligence sharing. I have absolutely nothing against the IS program. I think they are a brilliant step in the right direction. But this is one of the questions, this is one of the challenges that we face, one of the, the seesaws, right, the balancing acts that we must be aware of while we're working with the IOCs, right? So anyway, enough about the it, but let's try to get to the how, right? So basically, this is what happens, right? And that's the spoiler part. So people will get the IOC data and they'll try to do detection with it. Because, wow, yeah, this thing is telling me that there's a potential malware because of this. So let me try to use this to find things in my network where machines are potentially infected. And people just get immediately blinded by the amount of false positives and the amount of uninteresting or unreasonable matches that come out of this, right? And this comes partially from aging indicators, right? Things that are probably not reasonable anymore or not actionable anymore, and partially from people making actual mistakes on and putting data on IOCs. I mean, I have seen, again, $500,000 threat feeds consistently sneaking Google DNS IP addresses in their feed, right? And it's like, it's not that they don't fix it quick, but if you catch them on an offbeat, right, when those things are active, you might potentially be, again, if you are in this full automation mode and alerting on everything, you might get tripped on that. You generate a few thousand alerts, and then the whole credibility of your process, of your team just tanks, right? What people end up doing, which is, I think, a little bit sad, it's a little bit of underuse of the actual tool, of the actual data, is, okay, let's use it for context. So if I have something else alerting, right, if I had an IDS match, I had an endpoint thing come up that's reasonable enough for our investigations, I'm going to then query on the threat intelligence data to see if there's relation to what other people have done. Again, there's absolutely nothing wrong with that. It's a perfectly valid enrichment strategy for your incident response, but I still think we're underusing it, right? And this is one of the problems that I kind of set out to solve. And how can we try to have dependable alerting coming from IOCs and threat intelligence kind of things? So anyway, it's not supposed to be that bad, right? Let's try to work together. Let's try to reason some ideas and see if this is something that can actually come up. Because one of the points that I have, and thanks for David for contributing a slide to every single presentation on this summit. The thing that makes analysts effective is actually learning from the examples, right? So you see that the most successful teams, they will use the data that they have, the IOCs that they have, the network markers that they have as, okay, this is actually a sample of what this specific actor or this specific malware is capable of doing, right? And when I look at this, right, in context to maybe other data sources and other things that I collected, then I can try to derive the higher level on the pyramid kind of indicators and kind of markers that I can use. So then I can extrapolate, I can try to figure out where are these people coming from, right? What is the underlying infrastructure, right, that these people are potentially leveraging on a specific point in time, right? So and I obviously don't have to tell you guys this, but in a way everything is connected, right? You can very easily, if you dig into this, find this pivoting point, this relation points. It's what we do, or most of us should be doing on something like Maltego, or I don't know, if you are on the higher pay end of the scale, maybe Palantir, but I don't know, it's all up to you and how much money you have. So what actually happens in a way, and this is a very simple bastardization of what the process is like, right? If you're tracking for Frosty Penguin, right, and you want to build a report on Frosty Penguin, right, you're going to have a customer of yours, you're going to have an organization you're at that you suspect that's related to that, and you are finding a piece of malware, you're reversing it, or you're detonating it and figuring out what pieces of infrastructure it's talking to. Then you learn from these pieces of infrastructure, you try to expand your knowledge on that, expand the indicators, maybe the person who registered it, maybe the data center where these IP addresses are hosting, and then you do some back and forth between, okay, let me try this new batch of indicators to see if I can find new matches on my environment. Then you end up finding new pieces of malware, and you go back and forth until, you know, it's iterative until you have nothing else to look at. And then, hopefully, you found everything. You go into containment, right? You go into, you try to shut down everything at once. Again, this is not an IR talk. You guys should know what to do. But there's this rhythm to this discovery. There's this rhythm to this expansion, right? Which, again, is also codified a little bit in the hunting practice, right? And then you catch all of them, and you publish a report, and you're famous forever. And you get a lot of leads and things like that, right? So, given that there is so much, there's so much use, right? This is something that's so effective to try to figure out, again, the underlying infrastructure, the underlying pivoting points, right? Everybody will try to, okay, I've seen this IP, I'm not really sure about it, but let me see where this IP goes, let me see what domains connect to it. Can't we try to apply some sort of algorithm to it? Can we try to find some way to evolve from this like gut feeling, this is what I think I should do, to something that's a little bit more principled, right? So the experiment here that I'm going to run you guys through an example, right, is basically get all the IOCs that you have, or all a subset of the IOCs that you want, right? Enrich them with whatever enrichment data you have available, right? So I give some examples there of things you can do to IP addresses and for things you can do on domain names. Again, we're focusing on network indicators for this specific exercise. But if you were talking about endpoints, malware artifacts, right, you might be interested in what mutexes a specific executable creates, or registry keys they write, which directory on the registry they write. You know, you can start to go crazy a little bit on that, but you're trying to, again, finding points of commonality there where these things might aggregate, right? So there's a tool here that I wrote a couple of years ago, right? And exactly can help you gather some of the IOCs and enrich them, right? You can actually also get passive DNS data on that if you're a far-side customer. So let's talk about RIG, exploit kit, which I'm pretty sure most of you are familiar with what exploit kit do, and that RIG is a family there, right? So specifically, this is a window on October 20, last year, 2016, right? And I'm singling out two specific, these are domain registrant emails, right? From a sample of these October 2016 rigs, right? And I'm singling out two because they have two different characteristics, but I want you to figure out, there's a small bit of concentration on these IOCs that I had on one specific guy from Yandex, Mr. A. I'm not going to try to pronounce the last name, right? And we have a little bit of 33 there on Mr. Rob Cross, right? So that's interesting. I see some concentration there, right? So let's have a look at what these guys are doing. So poor Mr. Robert Cross seems to have been fallen victim to a domain shadowing attack, right? Which is something, again, if you're not familiar, it's the idea that someone compromised his registrar account, specifically on GoDaddy, and started registering subdomains under the domains that he owned, and then using that to again, put on landing pages that will try to deliver malware to you. And it's such a sad story because it looks like this guy works making wedding pages, right? It's all like two names, you see? It's like such and such, right? And someone is hijacking these guys like wedding web page business to serve malware. It's a truly, truly sad story. And he's probably not even aware of it, right? Or at least wasn't on October 16. But you can see that probably if you went to a web page that was registered by Rob Cross, especially if you don't have many friends who are marrying, right? That looks like more likely to have been something that was serving something malicious than actually something legitimate. So this is something that we might want to keep track of, right? The other example that we had was specifically the Yandex folks, right? The Yandex guy. And we're talking about, this looks much more clearly like he was registering those domains for use, right? And then you could think about, oh, so maybe a good strategy would be, oh, I'm going to get this domain, I'm going to find all the other domains that this guy has, and I'm just going to block this, right? But again, if you remember from this example, right, you're probably killing Rob Cross's legitimate business right there, right? So that might sound like a good strategy, but it's not a good strategy on the long run. And I'll give you some other examples where you can try to figure out these aggregations where maybe just figuring out, oh, there was something bad about this, so maybe I should block it. It's not the best possible scenario, right? So just to give you the associated example, we can do the same thing for IP addresses, right? This is specifically autonomous systems, right? We see IT grad with an interesting concentration there. And this, again, this is the same data source. And of course, Russia, right? And I'm not trying to pick on Russia or my Kaspersky friends. We are not here anymore. So the point being that you see some concentration, right? You see that we're actually learning something about how many of these bad samples of data that I have are specifically positioned on certain different places, right? So if we try to aggregate this data, maybe we can try to get a score. We can try to get a bigger view of which one of those places, which one of those potential pivoting points are more risky for my organization or not, right? So specifically there, right, when I'm just totaling the ones, the rig IOCs that I have on the domain, on the registrant emails, right, we're talking about this guy, Stevie Malone, was very, very prominent with rig at the time. So just quick fun note, this same domain now is actually being very active on registering sundown domains, right? Sometimes they reuse, they change the actual toolkit they're using, but this is actually the same, probably the same actor, right? So you can start to think, well, if anything is above 40 there, maybe I just want to block it, right? But you see our Yandex guys right there on 15, so maybe just the numbers are not great, right? Even though when you look at the AS numbers, right, the first one is OVH. Again, OVH is not the best because it's very easy for you to sign up for an IP address there, but there's a lot of legitimate stuff going on there, right? I probably don't care about King servers, which is a notoriously bulletproofing hosting place. I probably don't care about IT grad unless I have legitimate business in Russia, but I can't really shut down OVH, right? It's a hard call, right? But maybe if I get enough signals from each one of those connectedness, right? Each one of those, how many bad stuff I'm seeing from those things in aggregate, maybe I can go further to make a decision, right? And this is, of course, the more extreme example from those rig things, which is when you're talking about what's the top level domain, right? You don't want to block .com. You don't want to block .org. Your career as an incident responder will be very, very short if you just block .com on your organization. But it's undoubtedly the one that has the most rig, right? But why do we as fractioneers, right? And everyone in the room, yeah, I can't block .com. Why do we know that? Why is this something that's really encoded in our minds? It's because we know that, well, there's some okay things in .com and .org. Actually, it's like overwhelmingly okay to go to .coms and .orgs as opposed to going to .tops or .xyzs, right? So this is the first equation of the day, which, again, guys, don't be scared. This is very simple, right? I'm just doing a division there. I'm just trying to figure out, given my knowledge, right? And again, this varies from analyst to analyst, organization to organization, right? How much bad stuff I know about this specific pivoting point. And when I say pivoting point, you think I'm grouping on AS, I'm grouping on who is registrant or registrar or all those things. Imagine all those that we talked on a few slides back. So how much of it is bad? What's the percentage of bad versus the percentage of good that I know about, right? So you can try to create a gut feeling of, again, what does good look like? What does a good pivoting point? What does a bad pivoting point look like? And of course, some people will, wait, good places, where do I buy a feed from that? You actually don't, right? I definitely don't recommend you getting Alexa 1 million and treating that as good. But there's actually a lot of data that you can gather from your own telemetry as a company to try to figure out things that should probably be considered normal. So people who know my machine learning work knows that I'm very, very negative about anomaly detection and all these UBA kind of things, because if something is rare, it doesn't mean that it's bad, right? And we spend a lot of time looking for rare, when actually, again, it's most probably just a waste of time. But the converse is usually true, because there's such an overwhelmingly number of normal or not or benign communications in a network versus things that are potentially bad. So if something is very frequent, the likelihood that it's actually not malicious is pretty reasonable, right? So we can try to work on those things. Again, be careful. You can get shallow scoops from whitelists, right? But it's, again, if you're sitting on the analyst chair, right, as a human being, you usually know what's normal in your company or not. And this is encoded on you having exposure to people doing things in your network. So there's definitely some mix here that you can find that will work for you. And then you're going to be able to compare what's good and what's bad for your specific organization on a specific period of time. So when we apply that formula to those examples that we're talking about, we can start to see where these applications and these ideas, they start to make sense. So IT grad, you're actually looking at, and this, again, was a specific day on a specific group of customers that we have, right? Only 87% of the data that we had coming from IT grad was recognizably bad, as opposed to stuff that we had recognizably good. And wow, that's a pretty large number. So yeah, maybe I should consider blocking it. But it looks even worse when you compare the 87% to the 0.6% of maliciousness across all the different ASs that these specific group of customers went to. So the idea is, if they went to an average ASN, and I know that sounds weird, but if you just pick a log entry at random and look at the IP address they went to, there's only like a 0.6% of chance that AS, that the place they were going to on that AS was bad, right? So when you compare those numbers, it's very striking. There's a huge difference between what is the expected maliciousness, and I hope I'm not losing the audience here, right, against what is a normal, right, AS for them, right? When you go to country and you go to TLD, right, it becomes clearer that actually this difference between what's usual in the environment and how bad the specific place I'm going to, right, to tell me if my gut feeling is gonna fire to I should be blocking this or not. So you see the .org TLD is only 2.9% bad stuff, right? But the average TLD is 1.9. So it's pretty much even. It's not much more than, it's not even double, right? So one important thing here is if you have some very big outliers. So something comes to you as very, very malicious, right? Oh, this has a confidence 100 from my feed. And then all the data that you look at as the A assets from, who registered it all looks very low. That's usually a very clear sign that that thing that you just ingested right there is a false positive, okay, from the feed. So let me just get what we were talking here on this slide, the idea that actually the ratio between how much this specific place I'm visiting under the overall ratio of all the things, that's the number that matter, right? So I'm going to throw a slightly more complicated equation here, right? The only thing I'm talking about is that on the bottom there, it's the sum of all the ASs, or all the registrars, or all the different things. So for each different PP, which is a pivoting point. Everything this slide is telling you is what I was telling you on when we had the other slide up with the example. So no need to be afraid of this slide. I just want to have things written down, because if people want to try to reproduce, this is much more precise than me just blabbing about and waving my arms, right? So so here are some interesting characteristics of the idea of this rating, right? So this is actually a log graph. This is a log 10 graph, right? So this is me looking at, for a specific ASN, out of almost 9 million observations from different customers that we have, how many ASNs I had, how many communications I had, which had an ASN with a maliciousness rating 0 or very close to 0, up to 150-ish, which was the highest number we got for that period of time, right? When I'm telling you this is a log graph, which means that this is actually, you see it's going from 10 to 1,000 to 10,000 to 10 million, right? If I was to plot this on the normal scale, you would only see one graph, or one bar here, and everything would be very, very, very close down, right? When you have one of those graphs, which is a log graph, and it kind of looks like it wants to do a slope here, it means that this is a very, very long tail, which is kind of what we're looking for, right? We know that the vast majority of places that people go to are benign or should be benign, right? So if we're creating some metrics to try to, again, open our understanding of if something is malicious or not, it has to respect those characteristics of what actually happens in real life, right? We have a spike at the end there. Usually, it's usually an artifact of those calculations. It's like, it's a place we only heard about bad things. So there's usually a spike at the end, right, which accounts for sometimes our incomplete information. I'm sure there are ASs which are 100% bad, but that number shouldn't be that large. It's just that maybe because there's not enough coverage from the customer has never gone to a legitimate place on a specific AS, we can't really know if there are good things there. There's no actual evidence of that, right? And the other example is TLD, right? So it's pretty much telling the same story, but from different perspectives. This holds, right, from different kinds of pivoting points. Again, I haven't solved a few problems here. I've gave you some more things to measure that were probably going to be more helpful to understand, what kind of knowledge or what kind of value you're potentially getting from getting those feeds in. But what are the cutting scores? Should I have a cutting score? If something is above X, I should block it. Should I get multiple pivoting points and look at multiple pivoting points and then have a combined score between them? What's the weights? What are the weights I should be doing that? And again, this is a very, very hard question to answer manually, right? As in, there is probably for each organization, there's a different sense of how much risk they want to have, how much they would rather have a false positive than a false negative, right? Or how much I should feed the whitelists or not. So there are some challenges with, again, finding out what the right mix and the right weights are to actually implement this. But it would still be an interesting visual weight when you're trying to enrich, when you're trying to understand from a specific IP address what those things are. So let's imagine that we had something magical that was actually able to solve all these challenges of manually choosing weights and creating things that are very, very Yeah, this is amazing. That would actually be able to create different weights and different things. Like, I don't know, machine learning, right? So you would probably get something like this. This would be an actual example of things that you would be able to see, right? You're talking about a specific customer, a specific environment where you know that one thing is bad, you have actual information from one of the domains, right? And then the system is able to place that there are relationships on specific ASs or specific BGP prefixes on specific name servers, right? And again, expand this knowledge and find other things that are potentially related to the same campaign automatically, right? Without actually having to have those entries there, right? On this specific example, of course, using the same IP address was determinant, but was also determinant the whois. You see there how the whois name servers have a very high kind of tag, right? Because it was actually the same. The guy was registering those domains, right? Which again, visually, they kind of seem similar, but that really wasn't what caught them. What caught them was the fact that they were using this, right? So several different layers, several different places. So Shia is very proud because he did this magic and we have something to show. So I just want to leave you guys with another idea, right? It's one thing that I've been working on, and I think it's almost there, but it's something that I want to share with you because it ties into the threat intelligence research that I've been doing. And I mean, this is the perfect audience. I would love to hear your feedback on this specific ideas, right? So the biggest criticism that I had when I did the TIQ test research, right, which was, again, the idea that you could compare different feeds amongst each other and figure out what's the overlap and all those different things. And like, okay, it's all fine and good. I can compare a feed to another, but what's the best feed, right? Can I score a feed? Can I put a number to it, right? Which ones are the best, right? And again, good, best are very, very loaded words. I think the best we can potentially do, right, is to figure out if something is applicable for you, right? If you are on the camel side of the house, it's probably if it's actionable intel for you, right? But with telemetry, which was something that I didn't have a lot of when I first got started on the ideas of TIQ tests, you can try to approximate what actionable or what good or fit for purpose looks like in your environment. So I'm going to show you a few concepts, a few ideas. Don't read too much into them because they are from a specific example. So I'm not trying to bash any feeds specifically here. But one thing that I think is super relevant if you're trying to measure what is the value of a specific feed in your organization, what is the alert accounting that you have? Which I mean by that is, let's assume you alerted on all these IOC matches, right? They went to somebody's trash folder somewhere, right? But which one of the alerts that came from specific feeds actually translated to actual incidents or actual things that your team they deemed that they should investigate, right? So the reason why I can do these calculations very precisely is because I'm cheating in the sense that what I'm considering to be a right match, what I'm considering to be an actual incident, it's something that my research and our tool actually flagged as an incident. So it's a little bit self-serving, right? So I'm not saying that that's the measure you should necessarily be using, but it's a good way for you to understand as in how much this specific feed is feeding me things that don't matter for me versus things that actually make sense, it actually helped my investigation going forward. And even more importantly, what's the unique percentage of those? So how many feeds, how much data I got from this feed and only this feed that was determinant for me in uncovering a potential incident or uncovering a breach inside my network. So specifically on that one, so you guys are probably familiar with the Aggregation series, right? They have a bunch of different trackers. So on this specific example, again, it was a slice of time over several different customers. 100% of the things that were uniquely contributed by the Fiodo tracker, which is usually DryDex or things, they dabbled on TrickBot recently. were actually only from them and were determinant, were confirmed as things. So these are some ideas for you guys to play with as far as the use and the utility. And this is something I am, again, attempting to codify to a score. And it's something that probably later this year I should have a different presentation around this. But this is something that I definitely want your input if you have tried to do this, right? And if you think those techniques are interesting. So again, the main problem here, right, is what is a valid alert? What is a valid incident, right? And again, this will come from your IR process more often than not. This is definitely something that I cannot advise you with, right? So again, if you do your IR, you got some things you can search on. If you do actual threat intelligence generation, this is also something that we can check on. So, and I have to mention Rick's work on my threat intelligence beats your threat intelligence, right? The number is not relevant. The amount of stuff that you have is really how much of it was useful. So, and again, there's a lot of challenges. Sadly, there's no magic this time. You actually have to improve your IR processes in order to have this thing to compare. But anyway, it's an interesting idea that I want you guys to, I'd be interested to see what your experiences with this are. So anyway, I just want to leave you with the idea that, and I'm pretty sure this is the wrong room to say that. This is something that you guys already know, but and I love again, the more traditional intelligence focused guys using the term finished intelligence, which is interesting in the concept that this is a report that has a story beginning to end. But what I want to say to you is that the IOCs are not actually finished tools for you to use, right? If you look at them as tools, as things that are finished for consumption, right, you're probably facing them in the wrong strategy, right? There are things that you should be learning from, you should be exploring from them in order to have really efficient detection based on those specific signals. And again, what I'm trying to do here, and I'll be trying to continue to try to do, is how much automation really we can coax out of these things, right, to make our job just a little bit easier. And with that, and 20 minutes over, I thank you.